Hey there, Quadratics Made Easy here, and today I'll be talking about factoring. Factoring basically has 6 methods, factoring quadratics in specific. These are the 6 methods we learn in grade 10 and use in grade 10. The first one is common factoring. This is definitely the easiest method. In this method, what we do, to common factor a quadratic equation, we find the HCF, or the highest common factor, also known as the GCF, or greatest common factor, of all the terms in the quadratic expression. The HCF is taken out and placed in front of brackets. The expression inside the brackets is obtained by dividing each term by the HCF. So here I've written 12 is the so the expression here is 12x squared plus 144. 12 is the GCF of all the terms here. 12 is common factored out. So when we common factor out, we write 12 outside the brackets, and then that's x squared plus 12. So that little kind of box I drew, that's basically to show that this is the final answer. These little markings on the side mean absolutely nothing. The second method we're going to see is factoring by grouping. In this method, we have to start off with 4 terms. In this kind of method, we factor the quadratic equation quite easily by common factoring in groups and then express it as the product of 2 factors. Here we have an example: 2x squared plus ay minus ax squared minus 2y. We have to kind of shuffle the terms over here. We make 2x squared minus 2y minus ax squared plus ay, so that we get that common bracket right there after we common factor out from these 2 terms as groups. So then we have one group of this bracket and one group of this bracket. We common factor out this bracket from the entire part, and then we get this 2 minus a, whatever is that left over, 2 minus a, and x squared minus y. Now let us look at the third method, which is simple trinomial method. This is used when a equals 1. Okay, what is a? Used only when a equals 1, and trinomial can be expressed as ax squared plus bx plus c. That is the standard form of a quadratic equation. Here we have an example: x squared minus 13x plus 40. So in this example, here a, which is the coefficient of x, equals 1. What we have to do in this example, we look at the value of c, that is 40, and the value of b, that is negative 13. So we have to come up with 2 such numbers, which when added or subtracted from each other or added together, which evaluate anyhow to negative 13, and the same 2 numbers have to multiply together to give positive 40, that is c. So those 2 numbers have to evaluate by adding or subtracting to negative 13, that is b, and have to multiply together to give c. Such 2 numbers are negative 8 and negative 5. So basically what I did here is I split 13 into negative 8x minus negative 5x. If we add both of these, we're going to get negative 13. And if we multiply negative 8 and negative 5, we're going to get 40. Then we common factor, we do factoring by grouping over here, and we get this. This is the factoring of a simple trinomial, where a equals 1, and it can be expressed in the standard form of a quadratic equation. Now let us look at our fourth method, which is complex trinomial, when a is not equals to 1. Used only when a not equal to 1, and trinomial can be expressed as ax squared plus bx plus c. So here a is not equal to 1, it is 4. And we have 4x squared negative 35x plus 49. So our method kind of slightly changes over here. Instead of just looking at our c value, we look at we have to find 2 such numbers which when added or subtracted, added together, or evaluate, which basically evaluate to negative 35, that is the b, and which when multiplied, these 2 numbers have to equal to AC, which is the product of A and C. In this case, the product of 4 and 49. So we did that, and we found out that 4 into 49 is equals to 28 into 7. And we found 2 numbers, such numbers as negative 28 and negative 7. Negative 28 and negative 7 when evaluate to negative 35, and negative 28 and negative 7 when multiplied give us what is 49 into 4. So we use these numbers, then we factor by grouping in the next step, and then we get our factored form, complex trinomial. Now let us look at the fifth method, difference of squares. This method is used when both the terms are perfect squares and there is a negative sign between them. This follows the identity a square minus b square equals to a plus b into a minus b. What is an identity? Algebraic identity is an equation that is always true for any kind of value which you put into that equation. So if I put 50 instead of a, and if I put like I don't know, 75, this would be true. So the right hand side is always going to be equal to left hand side, no matter what numerical value I put in these instead of these variables. So let us look at an example. 36x squared minus 49. We use the identity a square minus b square equals a plus b into a minus b, and we just put it right here, right there, because 36x squared is a perfect square, that is 6x whole square, and 49 is 7 square. Now let's look at our last method, which is perfect squares. This method is used when the quadratic equation or the quadratic trinomial can be expressed in the form a square plus 2ab plus b square, or a square minus 2ab plus b square. This follows the identities. This has two for them. It can be two cases. A square plus 2ab plus b square equals a plus b whole square, or a square minus 2ab plus b square equals a minus b whole square. You see why it's called perfect squares? Because it evaluates to a plus b whole square, which is a perfect square. It's a perfect square term. Or this. So let us look at this one over here. X squared minus 14x plus 49. X squared, well, it's x squared. And the middle term, that's 14, we put that as plus 2 into 7 into x. That is 2 into a into b. A here is 1 and b here is 7. As we can see, 49, which is supposed to be b squared, is 7 squared. So b is 7. And, well, it's x plus 7 whole square. So these are our 6 methods of factoring. We can use these to factor the quadratic equations in any way we want. Thank you.